We saw this theorem in the last video and we considered that if the limit of the absolute value of a sub n as n goes to infinity is 0, then the limit of the original sequence is actually equal to the same thing, which is 0. The last video was longer than I anticipated. Hopefully this one is not. So I want to consider some examples about sequences. We are asked to find the limit of this as n tends to infinity. Well, to find this limit, I'm just going to divide both top and bottom by the highest value of n to get 1 over 1 plus 1 over n. We actually saw this limit in the last video. This is going to be the same thing as 1 over 1 plus 0, which is equal to 1. And that's just all for this. The next example, we are asked to compute this limit. Well, we want to find whether the sequence defined by this is convergent or divergent, or how do we do that? Well, I can say that this would be equal to the limit as n goes towards infinity of n is a positive number. So I can write that n as square root of n all squared divided by square root of 10 plus n. I'm doing this to see if it's possible to write everything in terms of square root, and it's possible. So this would be equal to limit as n tends towards infinity of the square root of n squared all over 10 plus n. The highest power here is n squared, so this is going to be equal to the limit as n tends towards infinity of square root of 1 over 10 divided by n squared plus 1 over n. If we divide this by n squared, we get 1 over n. If we take the limit of this, we are going to get square root of 1 over 0 plus 0, which is something as square root of 1 over 0, which is infinity. So what does this tell us? Therefore, if we define a sequence, the sequence defined by a sub n is equal to n over square root of 10 plus n is divergent. Because this limit does not exist or is infinite, this sequence diverges. It doesn't converge. Now we are asked to find the limit of this as n tends towards infinity. Well, notice that both natural log of n and n actually goes to infinity as n goes to infinity. So this tells me that if I take this limit ordinarily, I'll get maybe an indeterminate form of infinity over infinity. Can I use L'Hopital's rule here? Maybe, maybe not. Well, we saw a theorem 3, that if we define this sequence to be f of n equal to natural log of n over n, then we want to find the limit of f of n, but we can consider a function, consider the function f of x equal to natural log of x all over x, then limit as x tends to infinity. We can actually apply this L'Hopital's rule to this because the function is continuous. As x goes to infinity of f of x will be equal to the limit as x goes to infinity of ln of x over x, and this will give us an indeterminate form, so we can apply L'Hopital's rule here. If we apply L'Hopital's rule, we are going to get limit as x goes towards infinity of 1 over x divided by 1, and this basically will give you 0. Therefore, by theorem 3 that we saw in the last video, I'm just going to call theorem THM 3, we have that the limit as n tends to infinity of f of n is equal to 0, or a limit as n tends towards infinity of natural log of n over n is equal to 0. So that is the limit. Before we leave this video, let's discuss this problem. We are asked to determine whether this sequence defined by -1 to the power of n converges or diverges. Let's write out a few terms of this sequence. It's defined as if I'm going to write this will be equal to, the first term will be -1, second term will be 1, third term will be -1, fourth term will be 1, fifth term will be -1, sixth term will be 1. Like that going, my nth term is this, and this goes this way towards infinity. Now this is alternating between -1 and 1, so we don't really know whether at infinity this is going to be 1 or it's going to be -1. So we say that the limit of this does not exist. So since an alternates between -1 and 1 as n tends towards infinity, a limit of an was I given? Yeah, an as n goes to infinity, which is equal to the limit of -1 to the power of n as n tends towards infinity, does not exist. Does not exist. So what does that tell us about the convergence or divergence of the sequence? Since the limit does not exist, therefore the sequence is divergent. The sequence is only convergent when the limit of the nth term is a finite number. We'll look at more examples on this in the next video.